Welcome, students. Please keep yourself tuned in for the fifth edition of Lead Masterclass. We'll be going live soon in a couple of minutes with Mr. Debapriyay Mukhopadhyay, your instructor for the mental math session today. Students, in the comment box, do tell us how excited you feel about today's masterclass. Mr. Debapriyay will be telling us how to have some fun with mathematics and how to solve math problems more quickly and more fastly. So stay tuned for an exciting session ahead. Thank you. Hello, everyone. Welcome to the fifth edition of Lead Masterclass. This is your host of the day, Himanshu. At Lead, we ensure that our students should not only be equipped with excellent academic education, but also with the skills that help them to succeed in life. Maths can be fun too if students can relate it to real life and are taught in a fun way. To remove the fear of maths in students, we are presenting a Lead Masterclass on mental mathematics today. Mr. Debapriya has founded the blog Ganit Charcha, and under the umbrella of Ganit Charcha, he and his team work in popularizing mathematics amongst young school-going students. He has been a corporate professional for the last 20 years and is currently associated with Behar as a senior product manager and is working in developing solutions for cyber defense too. Sounds interesting, right? Now, kids, without any further delay, let's hear it from Mr. Debapriya. Mr. Debapriya, over to you.
Thank you, Himanshu, for this nice introduction. Good morning, everyone. So, in last day's session, beautiful things about numbers, and then we have gone through a few multiplication tricks. I hope you have enjoyed that session. Particularly, you have learned to uh, see beauty in numbers, or at least you should now try to see the beauty in numbers. And also, as I have told time and again, that every trick requires lots of practice before you can apply them in real life problems, before you can apply them in your day-to-day life, before you apply them to solve problems, you have to practice it time and again. And that's the key. Without applying them 20 to 25 number of times, you will not be able to see the time difference that you expect by learning these skills. So that's very important. Now, today also I will start with a few beautiful things about numbers, so that you start to see that how you can play with numbers, and slowly you get feel to play with numbers. So that is the main reason why I have put a few interesting things about numbers even in today's session. And then after that, I will take you over through some divisibility rules, basically the way you can quickly check whether a set of numbers or whether a number is divisible by uh, 2, 3, 4, 5, 6, 7, 8, 9, and by these one digit numbers or not, because while doing problems of HCF, while doing problems of factorization, while doing problems of division, these tricks come as very handy. So let us now start today's session. We will start with the magic, with the magic that I have for you. So let me explain, then I will ask you the answer. So what answer you have got? So in step one, you have to choose any three-digit number where the digit at the ones place and hundreds place differ by more than one. So what does it mean? So you have to choose a three-digit number. So you have one digit in hundred place and another digit is also in hundreds place, and some digit you have to put in ones place, but the difference between these two digits has to be more than one. So that means you cannot say, for example, choose a number like 494, or you cannot choose a number, for example, 495. You can choose, of course, 496, because the difference between the ones digit and hundreds digit is more than 2. So there is no restriction on which digit will be higher. So it could be 496, it could be 694. So you have to choose the greater of the two digits and just subtract to make sure that the difference between these two digits is at least more than one. So that is what you need to ensure. Now in step two, what we will do, we will reverse the digits of the numbers that we have chosen at step one. So reverse the digits and subtract the smaller one from the larger one. So if you have chosen 496, so by reversing the digits, you will get 694. Now you know that 694 is greater than 496. So you have to subtract 496 from 694. So that's what your step two. Now we will have to come to step number three. So again, the resulting number that you have got after subtracting at step two, you have to reverse the digits of that resulting number to get another number. So the example that I am talking about, so you have subtracted 694, you have subtracted 496 from 694, and you have got, say for example, 198 or so. Then again, you have to reverse the digits. So it will come around as 891. So that is what is being talked about in step number three. Now, what is step number four? These two digits you have to add. So that means the digit that you have got, the number that you have got in step three, and the number that you have got in step two, you have to add these two numbers. So that means the example that we have cited. So you have got in step two 198, you have reversed the digits at step three, you have got 891, and now you have to add 891 with 198. And what is the result? So that's the question that I am asking. Now I will ask each and every one of you to consider a three-digit number uh, the way I have mentioned in step one, and then execute these three steps quickly. And can you please let me know that what is the end result that you are seeing after step 4?
So students, I hope you all got 3 or 4 of the steps. Let's just wait for a few answers while we start to get in few answers. So I hope you can go through the steps all again right there on your screen. You have to select the 3 numbers that comply to all of these steps. Student, you can start sharing your answers in the comment box.
Yeah, just choose one 3-digit number with the condition that I have stated. And then you have to reverse the digits, subtract the smaller one from the larger one. You will get another number. The number that you get at step 2, you have to reverse the digits of that number to get another number. So at step 2, you have got one number. At step 3, you have got another number. Add these two numbers, and what is the result that you have got after adding these last two numbers? So that is what I wanted to know.
Sure. So Daksh Bikadia says that it's 486. Ivanya Vlog says that it's 698. Indu Lekha says that it's 486. Pinky Gautam says that it's 486. I think we have a lot of
How you have
students who
got
are answering.
how you have got 486? That is my question, because what is the number that you have chosen?
So students, you also have to tell us what is the number that you have chosen in order to actually got the output of 486. I think a lot of students are still typing the answer, which is 486. Poonam Singh is also saying 486. Rajiv Kumar also saying 486. So students, you
Yeah,
also
no,
have to
it's
tell us the number, how you have arrived to 486.
let me just tell you, the number should not be 486. I think there is something wrong in the process. So let me again walk you through an example so that you understand it better. So the number that I have chosen is basically, I have chosen 486 at step 1, say for example, and that's correct because hundreds digit is 4 and tens digit is 6. So it's fine because the difference is more than 1. So at step 2, what I'm doing, I am reversing the digits. So what I get is 684. Now 684 is greater than 486. So I will subtract 684 and 486. So that means I am going to subtract 486 from 684. So what I see is 198 is the digit that I am getting at step 2. So at step 3, you have to again reverse the digits of these new number 198. So what you are getting it as 891. So 198, if I reverse, I will get 891. So 1 will was in the hundreds place, so it will now be in the ones place after reversing. 8 was in the ones place, so after reversing it will be in the hundreds place, and tens digit will remain same. So if I now add 198 and 891, 891 I have got at step 3 and 198 I have got at step 2. So if I add these two numbers, I will get 1089. I will get 1089. So what I was expecting, that you should all be getting 1089. And irrespective of what you choose in step 1, it should always be 1089. Take another example. Say, for example, I choose 703. 703 is another 3-digit number that I am choosing. Now I reverse. So what I get is 307. 307 I am subtracting from 703. So what will be my answer? 396. So at step 2, I am getting 396. Now again, I have to reverse the digits of 396 to get another number in step 3. So what will I get? I will get 693. 396, if reversed, will give me 693. Now if I again add, what will I get? I will again get 1089. So if you are careful enough in choosing the right 3-digit number in step 1, you are bound to get 1089 at the end of step 4. And that's where the beauty lies. So I was expecting from all of you to get 1089. Anyway, you can try this trick of your own at your leisure, and you will be able to see that you should always get 1089. Now I'll come to the next slide. Yes, the number is 1089. Now we will see some surprising property or beautiful property of 1089. You can see it. So if I multiply 1089 with 9, so that is 9801, which is nothing but, if 1089 is multiplied with 1, then it's basically reverse of 1089. So 1089, if I reverse it, then it will be 9801. And that's simply nothing but multiplying 1089 with 9. If you multiply 1089 with 2, you will get 2178. And if you reverse the digit of 2178, you get 8712. And that's nothing but multiplying 1089 with 8. And similar relationship holds if you multiply it with 3 and if you multiply it with 7, if you multiply it with 4 and if you multiply it with 6. So these examples show you that how number can fascinate you, how number can enforce you to play with them. And the more you do this, the more beauty you will automatically see and the more interest you will feel in numbers. Now, if I see the next slide, you will see another interesting result. I don't think that I need to explain much over here. The relationship itself is showing everything. So we are starting with 1, and then if I multiply 1 with 9 and then add 2, I get 11. Then I add 2, that means I'm multiplying 12 with 9 and then adding 3, I'm getting 111. Then adding one more digit, which is 3. So that means multiplying 1 to 3 with 9 and then adding 4 with that. So you get 1111. Then 1, 2, 3, 4 multiplied with 9 and then you add 5 with that. You get 11111. And if you go on doing this, you get all ones when you multiply 1, 2, 3, 4, 5, 6, 7, 8 with 9 and add 9 with that. These type of identities are plenty in number. If you take a look into literature, if you take a look into the different uh, blogs or different mathematics notes, lecture notes, basically, which talk about beauty in numbers, you will see many of these patterns being explained there. So at your leisure, I will urge you, I will ask you to go through these identities, go through these equations, and try to apply different multiplication and addition tricks on them to figure out whether those identities are correct or not. So that will not only help you appreciate beauty in numbers, that will help you practice the different mathematics strategies or different mental math strategies as well. So you gain in two ways. You in you practice, that gives you chances to practice these easy equations quickly, and as well at the same time help you play with numbers. Now, given this, I will now start with the mainline topic that I have thought to discuss with you. Basically, that will help you in your course curriculum too. Basically, that's divisibility rules. So, divisibility tricks that I will describe over here today. So in many of the problems that you encounter in your course curriculum, you have to check whether a particular or a big number or maybe a two-digit number or maybe a three-digit number is divisible by one-digit numbers or so. So I start with two because any number is divisible by one. So that is anyway all of you know. So you don't need to think about that. But from 2 to 9, it's very important to know the rules through which you can quickly check whether a number is divisible by uh, these one-digit numbers or not. For 2, the rule is pretty easy, because any number which is divisible by 2 are even numbers, because that's what the definition of even number says. So you start from 2, and then you just go on multiplying it by the successive integers. So 2 with 1, you get 2 again. You multiply 2 with 2, you get 4. You multiply 2 with 3, you get 6. You multiply 2 with 4, you get 8, and so on. You get all even numbers. Another way of looking into it is basically any number, any integer, if it ends with 0, 2, 4, 6, or 8 at its ones place, is a is an even number. So I repeat, any number which has either 0, 2, 4, 6, or 8 at its ones place is an even number. So if it's an even number, then it's automatically divisible by 2. Nothing more you need to remember. So if the digit at ones place is either 0 or an even number, then that number is divisible by 2. So basically, I have emphasized on 0, but it's not required. I should have said if the digit is an even number, then that number is divisible by 2. If the digit is an even number, then that number is divisible by 2. So that's the trick. So 340 is an example where 0 is at ones place. So that means it's an even number. So it should be divisible by 2. 2, 3, 5, 4. 4 is at the ones place. So that means it's an even number. So it should be divisible by 2. So if it is not an even number, that means if it is an odd number, then it will not be divisible by 2. So what is an odd number? If the digit at the ones place is any of 1, 3, 5, 7, or 9, then that means it's an odd number. I repeat, if the digit at ones place is either 1, 3, 5, 7, or 9, then that means it's an odd number. And if it is an odd number, then it will not be divisible by 2. Say, for example, 341 is not divisible by 2. 2355 or 2353 is not divisible by 2. Now I will go to the next slide. So I will talk about divisibility by 3. So how will you check whether a given number is divisible by 3 or not? So the rule says like this: if the sum of the digits of a number is divisible by 3, then that number is also divisible by 3. So what you need to do? You are given a number. You have to take the digits out and sum over those digits. So you will get a number. If that resulting number is divisible by 3, then the number itself is also divisible by 3. How it is going to help you? Because after adding the digits, the number that you are expecting to get is much smaller compared to the number that you are given. Say, for example, in this case, 1236, it's 1236. Now, if you take out the digits and add it, you have 1 plus 2, which is 3, 3 plus 3, which is 6, and 6 plus 6, which is 12. Now, it's a pretty smaller number compared to 1236. And you can apply multiplication tables to figure out whether 12 is divisible by 3 or not. Yes, 12 is divisible by 3 because 3 4s are 12. So that means 1236 is also divisible by 3. So is the case for 2745. It's 2745. If you sum the digits, what do you get? 2 plus 7 is 9. 9 plus 4 is 13. And 13 plus 5 is 18. So 18 is divisible by 3. 3 6 are 18. So that means 2745 is also divisible by 3. So this is what the divisibility rule by 3 talks about. I hope you have understood. So let me check whether you have understood this trick or not. So let me give you one example, ask you one question. So what about 2353? Is it divisible by 3 or not?
So students, the question is 2353 is divisible by 3 or not? Let's just wait for some answers while students write in the comment box. So Varun says that yes, sir, it is divisible by 3. Sushma Pandey says that it's yes. Shivanjali and Arse says that it's yes.
2353. 2353.
Harminder Singh says that it's no. Atharv Nair says that it's no. It is not divisible by 3.
Yes, 2353 is not divisible by 3. Why? Because you have to add 2, 3, 5, and 3. So what you will get? 2 plus 3 is 5. 5 plus 5 is 10. And then you have 10 plus 3 is equal to 13. Is 13 divisible by 3? No. 13 is not divisible by 3 because 3 4s are 12 and 3 5s are 15. So in 3's table, you nowhere get 13. So 2353 is not at all divisible by 3. Since 13 is not divisible by 3. So the answer should be no.
Yes, we're
What
getting a
about
lot of.
7341? What about 7341? Can you quickly say?
Is it 7431 or 7341?
7341.
So student, it's 7341 is divisible by 3 or not? Okay, so Arjun Chauhan says that it's yes, it's divisible by 3. Uh, Divya says that it's no, it's not divisible by 3. Dave says that it's no, divisible by 3. Satish says that it's yes, it's divisible by 3.
Yes, 7341 is divisible by 3. It's not no here. Because 7341, you need to add 7, 3, 4, and 1, these 4 digits. So 7 plus 3 is equal to 10. 10 plus 4 is equal to 14. And 14 plus 1 is equal to 15. Now 15 is divisible by 3 because it comes in 3's table. So 3 5s are 15. So since 15 is divisible by 3, that means 7341 is also divisible by 3. So you need to try these rules to find out the answers correctly. Now I will come to divisibility by 4. So how will I check divisibility by 4? One simple way of thinking it as, basically, first of all, since 4 is an even number, that means it's divisible by 2. So the number which will be divisible by 4 should also be an even number. So if you are given any odd number, you can simply say that it's not divisible by 4. Say for example, 7341 is an odd number because 1 is at the ones place. So it will never be divisible by 4. So the only question comes when you are given an even number. So you are given an even number, you have to check whether it is divisible by 4 or not. Now remember one thing, that not all even numbers are divisible by 4. For example, 6. You know that 6 is an even number, but 6 is not divisible by 4. But 8, which is again an even number, is divisible by 4. 10 is an even number, but it is not divisible by 4. But 12 is an even number which is divisible by 4. But these things you can verify very quickly by remembering the multiplication fact, because it comes in 4's table and you can quickly remember these things and can apply. What about large numbers? How do you figure out whether a large number is divisible by 4 or not? So what do you need to do? If the number formed by taking the last 2 digits, that means you have to take out tens place and ones place. You have to take out the digits which are written in tens place. You have to take out the digits which are written in ones place. And you need to form an integer out of these two digits. And you need to check whether it is divisible by 4 or not. If it is divisible by 4, then that means the original number that you are given is also divisible by 4. And another thing is, if the last 2 digits are both 0, then that number is also divisible by 4. Remember this thing. So 65348, the example that I have given here, it is divisible by 4. Why? Because I am taking out the last 2 digits. That means the digits written at tens place and ones place. So I am taking out the digit 4 and 8. So the number that I get is 48. Now 48 is divisible by 4 because 4 12s are 48. You know that. So since 48 is divisible by 4, so 653448 is also divisible by 4. In the next example, you see that last 2 digits are 00, 12900. Since the last 2 digits are 0, so that means automatically it is divisible by 4. Now these tricks are not going to help you find out the quotient. These tricks are not going to help you find out the remainder. But these tricks are helping you figure out whether a particular number is divisible by small one-digit numbers or not. Now, where you will apply this? You will have to do factorizations for many problems. Say, for example, in HCF, say, for example, in LCM, you have to find out the factors, highest common factor or least common multiple. So you have to factorize. So when you have to do factorizations, you cannot start thinking about big numbers, whether a particular number is divisible by 31, whether a particular number is divisible by 47 or not. You have to start from the very beginning. You have to start with 2. Then you have to follow through with 3. And that's how you decompose your original number. And you will come across getting smaller numbers. And when you will eventually get a smaller number, you can probably think about checking whether a number is divisible by 17, 21, 23 or not. So these tricks are applicable there. Now I will come to the next slide. So what is divisibility by 5? So that's easy. You all know that. You know 5 stable. So one's digit keeps on alternating between 0 and 5. So 5 1 is a 5, 5 2 is a 10, 5 3 is a 15, and then 5 4 is a 20, 5 5 is a 25, and then 5 6 is a 30. So one's digit keeps on alternating between 0 and 5. You start with 5, then 0, then again 5, then 0, then again 5, then 0, then again 5, then 0, and it will keep on going. So that means any number which will have to be divisible by 5 has to have either 0 or 5 at its ones place. There cannot be any other number. So if you see any number other than 0 or any digit, if you see any digit other than 0 or 5 in ones place, that means that number is not divisible by 5. So the example given here, 65365, it is divisible by 5. 12900 is also divisible by 5 because 5 is at the ones place, and in the latter example 0 is at ones place. Had it been 12901 or 03, it would not have been divisible by 5. Now divisibility by 6, we will see divisibility by 6 in the next slide. So this is simple. You have to apply 2 tricks in combination to find out whether a number is divisible by 6 or not. So 6 is basically a combination of 2 and 3, because 2 into 3 is equal to 6. In a 6 you have 2, in a 6 you have a 3. So first you have to check whether the number that you are given is even number or not. If it's an even number, then you have to go for checking whether the number is divisible by 3 or not. The rule for that you have already learned. But if you see that you have got a number which is odd, you don't need to check whether the number is divisible by 3 or not, because since it's an odd number, it's not divisible by 2. So anyway, it cannot be divisible by 6. So you have to start first from figuring out whether the number that you are given is an even number or not. If it's an even number, you can quickly check that, and then you can sum up the digits of the number to figure out whether the number given is divisible by 3 or not. And if it is divisible by 3, then that means it's divisible by 6. If it is not divisible by 3, then it's not divisible by 6. Even then, if it's divisible by 2, because it's an even number. An example, 16. 16 is not divisible by 6. 16 is an even number. So 16 is divisible by 2. But if I sum the digits, 1 and 6, so it's 7. 7 is not divisible by 3. So that means 16 is not divisible by 6. On the contrary, if I take 18, 18 is again an even number. That means it's divisible by 2. Now, if I take the sum of the two digits of 18, so 1 plus 8 is equal to 9. So 9 is divisible by 3. That means 18 is also divisible by 3. So 18 is divisible by both 2 and 3. So 18 is divisible by 6. So 6 3s is 18. So that's how you can check divisibility by 6. Now I'll come to the next slide. So divisibility by 7. So this rule is a bit tricky. You have to master it in order to apply it. You have to practice it in order to apply it. You have to understand it first. So what we need to do here, the difference between twice the unit digit or one's digit of the given number and the remaining part of the given number should be multiple of 7 or it should be equal to 0. So apparently you will not understand this, but if I explain it with an example, then you will understand it. So I have to check whether 861 is divisible by 7 or not. So what is the digit in one's place or units place? It's 1, right? 861. So 1 is at the ones place. So what you have to do? You have to double that digit. So you get 2. Now you just forget about 1 from 861. What is remaining? If I forget 1 at one's place in 861, what I have is 86. Now I subtract 2, what I have got by doubling the digit at one's place, from the remaining number, which is 86, then I get 84. Now, if this 84 is divisible by 7, then 861 is also divisible by 7. That is what rule says. Now, 84 is divisible by 7 because 7 12s are 84. So that means 861 is also divisible by 7. Now you can apply it with a smaller example. Let me tell you one small example to understand it better. So 91. 91 is divisible by 7. You know that. How? 7 13s are 19 or 13 7s are 91. So what is the digit you have at one's place? It's 1. So you double that digit. So you get 2. Now you forget that in 91 you have 1. So you just discard 1 from 91. So what you are left with? You are left with only 9. So 9 minus 2, because you have doubled the digit at one's place. So 9 minus 2 is 7. 7 is divisible by 7. That means 91 is divisible by 7. So this is how you can check whether a particular number is divisible by 7 or not. Now, I ask you to try out one example. What about 917? Whether it is divisible by 7 or not. Can you try it out?
All right, students. So the question is 917, 917 is divisible by 7 or not? So you just have to type your answer in the comment box with a yes or no. So I'll repeat the question: if the number 917 is divisible by 7 or not. So Varun says that it's yes, it's divisible by 7. Sri Devi says that it's no, it's not divisible by 7. Seema says that it's not divisible by 7. Chitra says that it's not divisible by 7. Jyoti says that it's yes, divisible by 7. Abhinav says that it's yes, divisible by 7.
Yes, it's divisible by 7. Why it's divisible by 7? Because 917, so the digit at ones place is 7. So you have to double that digit. So what you get after doubling that digit is 14. 7 into 2 is 14. Now if you discard or ignore the digit 7 in the number 917, so what you get is 91. You just forget about the digit 7 in 917. What you have is 91. Now you have to subtract 14 from 91. So if I subtract 14 from 91, what will I get? I will get 77, right? 77 is divisible by 7. 7 11s are 77. So since 77 is divisible by 7, that means 917 is also divisible by 7. So that's how this logic or this trick can be applied. And for any number, how big it is, for any number, how big it is, you can apply this trick in succession. What do I mean by in succession? So the number that you are getting after subtracting the double of the unit digit from the remaining number may not come in if it is not that, then the remaining number to find it out. So let's first practice it on 3-digit numbers. So I will ask you to practice on 3-digit numbers to check whether a 3-digit number is divisible by 7 or not. When you are comfortable enough in applying this trick on 3-digit number, then you can probably go for a 4-digit or 5-digit number to see whether that number is divisible by 7 or not. But remember, you may have to apply this trick in succession, means one after another. Now I will come to the next slide. So it's divisibility by 8. So this rule is more or less similar to the divisibility rule by 4. So we have to take out 3 digits, last 3 digits. In the divisibility rule by 4, we have taken out the last 2 digits and checked whether that particular number is divisible by 4 or not. If that number is divisible by 4, then that means the original number is also divisible by 4. In this case, we have to take out the last 3 digits. That means hundreds place, tens place, and ones place. And the 3-digit number that I'm getting, if it is divisible by 8, then that means the original number is also divisible by 8. And if the last 3 digits are all 0, then that means the number is also divisible by 8. So 65344, this number I have to check whether it's divisible by 8. So I am taking out the last 3 digits. So 3 at hundreds place, 4 at tens place, and 4 at ones place. So what I'm getting is the number 344. And you can see that 344 is divisible by 8. 344 you can divide. 8 4s are 32. So remainder is 2. So 2 and 4 so 24. So 8 3s are 24. So that means that 344 is divisible by 8. Since 344 is divisible by 8, 65344 is also divisible by 8. Now for 129 000, so the last 3 digits are all 0. So you don't need to do anything. It's simply divisible by 8. So here there is a typo. 12900 is divisible by 0. Here it is written, so it's a typo. 12900 is divisible by 8. That is what I wanted to mean here. So that's divisibility by 8. Now the last digit with which we will check the divisibility, that's divisibility by 9. That's in the next slide, and it's to some extent similar to what we have learned in case of divisibility by 3. So in case of divisibility by 3, we have summed up the digits given in the number, and then the number that we have got is pretty less compared to the number that we are given originally, and we have checked out whether that small number is divisible by 3 or not, and if it is, then it's divisible by 3. And for all even numbers, it's needed to check because it could be even divisible by 6. So the rule says that you have to sum the digits. So in this case also, you have to sum the digits of the number, and then you have to check whether that number is divisible by 9 or not. So the same rule, just you need to sum the digits, and you have to check whether it's divisible by the small sum that you have got, whether it's divisible by 9 or not. So the example given here is 1, 2, 3, 3. So 1, 2, 3, 3. If I sum up the digits, so 1 plus 2 is 3, then 3 plus 3 is 6, and 6 plus 3 is 9. So 9 is divisible by 9. So that means 1, 2, 3, 3 is also divisible by 9. 2, 7, 4, 5. So if I sum the digits, it's 2 plus 7 is equal to 9, and 9 plus 4 is equal to 13, and 13 plus 5 is equal to 18. Now 18 is divisible by 9 because 9 2 is 18. So that means 2745 is also divisible by 9. Now I will ask you to check whether the number 7245 is divisible by 9 or not.
So the number 2745 is divisible by 9 or not? Student, I'll repeat the question for you. Is the number 2745 is divisible by 9 or not? You just have to type it in the comment box with a yes or no. Yes, so a lot of students are answering yes, yes, it's divisible by 9. Siddharth says that it's yes, divisible.
Yeah, right. It's correct. It's divisible by 9 because sum of the digits is basically 18. So 18 is divisible by 9. So it's divisible by 9. So I have a set of few exercises for you at the end. You can try it out. Any one of them you can try it out. At the last slide. So you can try it out. Say, for example, I will ask you to check the number B, 224256, whether it's divisible by 4 or not.
Yes, students. So the option B, which is 224256, is it divisible by 4 or not? Yes, students. So the option B, 224256, is it divisible by 4 or not? Yes, sir. So a lot of students are answering yes, yes is divisible by 4. The second option.
Yeah, it is divisible by 4. Now, what about number D, 364455, whether it's divisible by 9 or not? Number D, 364455, is it divisible by 9?
So students, option D, which is 364455, is divisible by 9 or not? Yes, so a lot of students are answering that no, it's not divisible by 9. Durgesh Mishra says that it's not divisible by 9. Pratiksha Throde says that it's not divisible by 9. We have a lot
No,
of,
it's divisible by 9. It's divisible by 9.
yes, so a lot of students have
You
now
should, you
starting
should
to
follow
answer
through
that
the,
it's divisible by 9.
yeah, you should follow through the trick. The trick says that you have to sum the digits of 364455, and if the sum that you have got is divisible by 9, then the number itself is divisible by 9. So what you get by summing all these digits? So 3 plus 6 is 9, right? And then you have two fours and two fives. If I pair one 4 with one 5, so 4 plus 5 is 9, and another 4 plus 5 is also 9. So that means you will get 27 by summing all these digits. 3 plus 6 is 9, 9 plus 4 is 13, 14, 13 plus 4 is 17, 17 plus 5 is 22, 22 plus 5 is equal to 27. So you have 27 by summing all these digits. 27 is divisible by 9, right? 9 3s are 27. So that means 33, 6, 4, 4, 5, 5 is also divisible by 9. Now you can try out different other examples given in book. You can try out any integer that you come across, any number that you come across, and can try out whether these numbers are divisible by 2, 3, 4, 5, 6, 7, 8, or 9. So these are only few numbers, 7 numbers with which you can try out and can list whether a particular number is divisible by which number or not, and automatically you will be readily be able to apply these tricks when you require those. So that's all that I have. If you have any questions, then you can ask me.
Thank you, Debapriyay sir. I think this was so enlightening. I think all of the students have really loved the. We are receiving actually a lot of comments saying that students have really enjoyed the session. So Deepa Giri says that I have really loved the entire session and this was really valuable to me. Uh, we have Dev Gautam saying that I love the session and it was really, really, uh, enlightening for me. While we totally, would love to continue talking to Mr. Debapriya for hours, we're really running out of time. And thank you so much, Debapriya, for sharing your journey and tips on mental health. This will go a long way to acquire one of the most important skills for thousands of students listening to you today.
Yeah, sure.
We would love to squeeze in like one or two questions from the, from the student app that we are receiving and the comment box as well.
Yeah.
So Radha Desyani asked if you can explain the divisibility by 3 again. So
Okay. So divisibility by 3 says that you have to sum the digits given in the number. So any number is comprised of a few digits, right? Say for example, 1, 2, 3. 1 to 3 is a small number, 123. So you have to check whether this number is divisible by 3 or not. Now you have to take sum of the digits written in these numbers. So 1 to 3 has got 3 digits. So 1 is at the hundreds place, and then 2 at the tens place, and 3 at the ones place. So you add 1, 2, and 3, these 3 digits. So if you add 1 with 2, you get 3. And if you add 3 with 3, then you get 6. So 6 is divisible by 3, right? Because 3 twos are 6. So since 6 is divisible by 3, that means 1 to 3 is also divisible by 3. So that's what the divisibility rule by 3 says. And that's how I have formed these exercise number 5. So 1, 2, 3, 3, 1, 2. So it's divisible by 3. You can easily check. Because the first part, 1, 2, 3, if I add the digits, it will give you 6. And the next part, which is 3, 1, 2, it's basically comprised of the same digits, just the positions are different. But if I take the sum, then it will again give you 6. So that means sum total of all the digits in these number 1, 2, 3, 3, 1, 2 is 6 plus 6, which is equal to 12. You can check that. The sum total of all the digits in these number 1, 2, 3, 3, 1, 2 is equal to 12. Now, since 12 is divisible by 3, 3 4s are 12, that means this big number, this 6-digit number 1, 2, 3, 3, 1, 2 is also divisible by 3. That is what this rule 3, divisibility by rule 3 says.
Thank you so much, sir. I hope rather this is clear to you now. So you have received a compliment, sir. Actually, Vishali Kumari Patel from Chandigarh says that I understood mathematics because of you, sir, because of this class today. And there are
Thank you.
actually a
That's a
lot
great
of,
compliment for me.
yeah. So Srinivas Yadav also says that, sir, thank you, sir. You are a brilliant teacher. I really loved learning mathematics with you today.
Yeah. I
So
hope that you will also follow whatever I have said, practice more, start playing with numbers, and automatically you will get feel fascinated with numbers and mathematics.
absolutely. I think practice would go a long way. And must say the quiz
Yeah.
questions were really exciting. And even more exciting was to see thousands of you really smart kids answering all of these very correctly.
Yes.
One important note, please do take out time to share your feedback on this masterclass. The link for the form is given in the description of this video and also pinned down as a top comment in the chat box as well. Please do fill out the feedback form. This will really help us to improve our masterclass for thousands of our lead students just like yourself. So, sir, finally we have come to the end of today's session. We hope all of us
Yeah.
will start and continue on our journeys improving our mathematics by practicing what Mr. Debapriyay has taught us today. Thank you, everyone, and thank you once again, Mr. Debapriyay, signing
Yeah.
off
Thank
from
you.
today's session. Thank you so much, sir.
Yeah.
Goodbye.
Thank you.